Hello, welcome everyone back to SAT Math Question of the Day. Professor Emeritus Seth Chaiken, Professor Emeritus, University of Albany, and Seth's brother Joel. Here we are here to help you approach SAT math questions. Today we're using a new application. Instead of Xiteboard as our whiteboard, we're using bit paper. So excuse us, it's going to look a little different, and we're going to figure out which one we like more. Okay, here we have a calculator question, getting toward the end of the sections, and this is not a multiple choice. I actually have to answer this thing. And today's Throwback Thursday, so we go back to a test, and that's 20 years ago. Okay, so I need to choose my pen. Oh, you see, this is what I mean. Oh, God, okay. Oh, you see, you have to get used to this stuff. Oh, there we go. Okay, we're back in business. Sorry about that. So all part of the learning curve, right? All part of the learning curve. Okay, here we go. It's a question where we have to do unit conversion. It's approximately there's a lot of stuff here, right? The pass is approximately equal to the number of inches. It's also equal to 16 small Roman numeral digits. Based on this relationship, 75 digits is equivalent to how many feet in the air is foot. Okay, Seth gave me the pleasure doing this. The most efficient way to do this is really a crazy, funky way, which hopefully you've seen in chemistry, called dimensional analysis. 75, the way you do it like this is you do 75, or I'm going to call it Roman digits, okay? Roman digits. And we want to know how many feet is the answer, right? Sorry for that line there, this little dot. So we have to do some sort of conversion. So we're going to do like a lot of things here, and we're going to use dimensional analysis to end up with feet. So now we have to read this thing. Oh, it's equivalent 16 Roman. Okay, it is also equal to, you got to be careful here. The pass of Roman thing is approximately equal to, okay, the inches, right? It is also equal to 16 smaller Roman digits. So why don't we convert Roman digits to pass? Okay? So if we want to do that, notice we're going to be crossing these off. Now let's read this thing. The pass, it is also equal to, one pass is also equal to 16 Roman digits. So now we're in passes. Now, okay. A pass, we want to convert inches to pass. We want to knock the pass out, and we want to then end up with inches. So we're going to be doing that. Now we have to read this carefully. The pass is equal to 11.65 inches. So we do 11.65 inches, one pass. And now we cross off these things. Wow, we're really close now. Now we have inches. We just have to do inches to feet. Well, we put the inches in the denominator because we want to cross off the inches. We put feet in the numerator because that's what we want. And we know that there are 12 inches in 1 foot. So the answer is 75 times 1 times 11.65 divided by 16. So in your calculator, because it's a calculator.
Divided by 12.
Yeah, divided by 12. Why would it? That's right. That's right. But and now to be safe, you want to do this. And to really get this question right, you want to knock all that out, and then you do this, and then you put this in the calculator, and whatever that is, that's the answer. Now, if you haven't seen dimensional analysis is so unbelievably efficient to do this problem. Otherwise, you're going to have to do ratios, and you're going to get totally confused. I hope Seth has another way to do it, because some people may not have seen dimensional analysis, but this is, you can see how cool this is. Isn't it cool? Like crossing out the units. Isn't that cool? Yeah. I love it.
Yeah.
So
yeah, I completely concur. I would recommend doing it exactly this way.
Wow. So if people haven't seen dimensional, now I'm doing it in the calculator. If people haven't seen dimensional analysis, then this is the time to learn it, right? Okay, so I get, this is crazy, 4.5507. To the nearest hundredth. To the nearest hundredth. Okay, so the answer in the calculator, I'm going to redo it, by the way, is 4.5507. Oh, the 7
Yeah.
got canceled. So to the nearest hundredth, Seth, do you want to take it from there? What is,
Yeah,
if
the
it's
nearest hundredth is
4.55 goes
4.55.
4.55.
Yeah,
Now, one should
4.55.
definitely redo this in the calculator just to be sure they got it right. So
Yeah,
I do 75
looks good.
times 11.65. Seth's going to do question of the day.
Yeah, yeah.
Yeah, I got 4.55 again.
No, that's beautiful. Yeah.
And there's
Yeah.
no intuition here. We have absolutely no idea whether our intuition is right here. We just have to trust the math. Because
Yeah,
we don't know anything
yeah.
about this stuff. We have no
Well,
intuition.
you know, it's a really complicated conversion because there are 4 constants.
Yeah.
So it's the dimensional analysis is the best way to keep track and to formulate a strategy to figure out how to combine the the 4 conversion factors.
Right.
Yeah.
In a one step, let's see if I can move things around. Oh, so like this, maybe?
I think by selecting them, you can move them around.
Oh, it's so.
You know, with the arrow icon that you used before.
Yeah. Here we go. You may see, when you learn units are basically ratio questions. So let me click on this. Hold on. So if you're going to do a simple unit question like miles to feet, you could just make a ratio. You just make a ratio to this. Miles, feet, and then you have 5,280 feet in 1 mile. So 7,000 feet is X miles. You see, this works great with 1 unit conversion. But if you get more than 1, this is you'd have to do this 4 times.
Yeah.
But unit analysis also works, right? If you have 7,000 feet and you want to convert to miles, then you just put the feet here, miles here, 5,280, 1, and then the answer is 7,000 divided by 5,280. So our little method works great too when you just have 1.
Yeah.
Okay.
Yeah, so let me just summarize by writing very clearly what Joel did. He took. I'm going to omit the numbers. He wrote. He used RO. I'm going to use RO.
Wait, people can't see that. So
by 75.
Seth, people can't see that. Wait. So now, see, this is. I'm sorry, everyone, but we're gonna have to. Oh, there we go. Okay. I'm sorry.
Okay.
Number 34.
Okay. My criticism is instead of using RO for Roman, was both of the units are Roman.
I used RD.
Oh, it looks like RO.
But I said RD.
Oh.
I said RD.
Okay.
I said RD.
Okay. I would rather use D for digits, right?
So do we really have to redo it?
Yeah.
So do we really have to redo it?
I just want to make it George clearly, so I'll use RD. RD. So we have RD times. Let's see, PES divided by RD times inches per inches per PES. See, it's unclear. This is incomprehensible. PES, and then you multiply that by feet per inches. And so the RDs cancel, and I like to show cancellation like this, sort of connect them.
I like to cross them out.
PES it cancels with PES.
Right.
Inches cancels with inches, and we get FT.
Get feet, yeah. Let me see.
Yeah.
And my problem here is my writing is so big. So maybe I'll use a smaller zoom because my writing is so this is a whole issue a bit with the bit paper. My writing is bigger than Seth's. It's a little bit of a problem. We'll try to figure this out.
Yeah.
I have to be
Yeah.
a little neater than I usually am. Okay, everyone, that's it. So
Okay, question of the day.
Try to practice dimensional, and this is called dimensional analysis. Try to practice it. It makes these questions doable. In fact, I think this really is probably the only way to do it. Okay, but I hate saying that. Okay, ready for question of the day. This is really cool about bit paper. We already have it programmed for page 78. Here we go. Boom.
Bingo.
Here we go. Now let me
right.
zoom it in a little. Let me try zooming at this. No, I can't zoom it in. See, that's the thing. I gotta.
All right.
Wait, stop.
Well,
not yet. Not
yeah.
yet. We're not ready yet. Okay.
All right. Just tell me when to go.
Go.
But question 13?
Question number 13. I think it's
all right. Question 13. I see it. Okay. So what's the deal? You have the star-shaped, star-like figure, and it says there 4 lines are drawn through the center of a rectangle shown above. What fraction, holy smokes, what fraction of the area of the rectangle is shaded?
Wait. I think I mentioned what is question of the day because someone may be new to listening to us.
All right, tell them what question of the day is.
Throwback Thursday. Every Thursday, we take a question from a test, from an SAT set that predates 2016, when the test really changed nature. The test had a lot more of these questions, which is, you got to really be smart for this thing, as opposed to just know your stuff. After 2016, the test really was, we got to know your stuff, as opposed to be brilliantly clever. So now this is a question from before. So you should do a question like this and say, thank God I'm not taking the test before 2016. Unless you love challenges. Okay, that's it. Question of the day. Throwback Thursday.
Okay, so this is a mystery. Okay. I looked at the problem again to see what information they give us that may help. Now, the critical thing that I observed in looking at it again is that the 4 lines are drawn through the center of the rectangle. Okay? Now, that is really critical to solving this problem. So here's the idea. This is the center of the rectangle. Therefore, because this is the center of the rectangle, well, opposite every shaded triangle across the center is another triangle that's not shaded, right? And those 2 triangles are congruent. So because it's the center of that, why? It's the center, and so the diagonal is bisected. So the length of yes, because it's the center, every one of the lines is bisected by the center. Every one of the line segments defined by the intersection of the line with the side of the rectangle. Each of the, how many line segments? 1, 2, 3, 4. There are 4 line segments. Each one is bisected by the center. In fact, so what I'll do is put in tick marks to show it's equal. These 2 lines are equal. These 2 lines have equal length. This line has length equal to this line. And finally, this line is equal to this line. So corresponding lines, 2 correspond for each pair of triangles. Corresponding lines on each side of the center are equal length, and the 2 sides are the angle between the 2 sides are equal. So we have side angle side equals side angle side rule for congruence. Therefore, opposite triangles are congruent. Therefore, each pair of opposite triangles has equal area. Half of that area is shaded and half is unshaded. Okay? That is true for this pair of triangles. That is true for this pair of triangles. And it's true for this pair of triangles. But that doesn't cover the whole area. Because there are these two triangles of which each of them is not shaded. This is complicated. And so what I'm going to do, let's see, what fraction is shaded of the whole thing?
This is painful.
So what I'm going to do is figure out what fraction is not shaded. Well, let's see. The fraction that's not shaded is, okay. Is the fraction that's not shaded is the fraction of 4 plus the fraction of 4, okay, plus a half. Oh gosh, this is confusing. Okay,
Seth,
let me back up.
Can I just say the answer already?
Oh, I don't know the answer. Can I figure it out myself?
Oh, come on. How could you not know the answer? How could you not know the answer? Once you said the clue how to do it, I was able to do it like this. How could you not know the answer?
The answer is not a half.
No, it's a quarter. It's a quarter. It's a quarter because you knock out these guys. You knock out these guys, so that's half the triangle. And then this you have a half of these cylinders.
Okay, right, yeah. So what I'm stumbling over, is realizing that the area of the two triangles named 4, that area is half. Yeah. So now I see that the area of the triangles that Joel marked in black is half of the whole thing.
I think so. I wouldn't bet my life.
We'll prove it. Try to prove it.
Oh, wait. I think so.
Yes. Okay. I could prove it. I think
so.
I could prove it. Okay. I could do better than thinking so. I know it.
Okay. Well, I only think so. I think so.
Why? I'm going to change color to blue for proving something. Now, here we go. I consider this, I concentrate on this part of the figure. Okay?
Right.
And wait a minute. That is, for this to be a quarter, then
maybe I'm wrong.
Yeah.
I may be wrong.
What I'm trying to see is that
No.
This triangle has the same area as this triangle.
If you go like this,
are they the same?
Symmetry. You just cut the symmetry, don't you? Don't you just cut the symmetry?
Well, clearly the top.
This is a quarter. This is a quarter.
It's not a square.
Doesn't matter.
Yeah, sure, no, certainly. Certainly, those opposite triangles have equal area. But the question is this one compared with this one? Especially when you have
because there's this symmetry. Right? There's that symmetry. Yeah. There's all the symmetry going on.
No. Let's draw a long rectangle.
Wait, we gotta move you a little. Hold on. because some people aren't see what you're writing. Okay, so we have to be nice to Seth.
Yeah.
We have to be nice to Seth.
Yeah.
Okay, there we go. We're nice to Seth. Okay. There's all the
Yeah.
symmetry because it's a rectangle.
Yeah, sure. No, it is a rectangle, right? Here's our rectangle. Yeah, certainly. Here's the center. Certainly. Can I use lines? Yeah, I could use lines. All right. Is this line and this line, right?
Yeah.
Certainly. Certainly, this area equals this area, and certainly this area equals this area. But how do you know
People
is
don't
A
see
equal
what
to
you're
B?
writing. People don't see what you're writing. People don't see
Can we
what you're
prove
writing.
that?
All I know is that the symmetry. Symmetry.
No.
You have a wait. This is like I got to get used to this stuff. Wait. You have a rectangle. Find out it's clear rectangle, right? It goes this way. It goes this way. So then this is this line. This is this line, right? Now these guys the black dot and the black dot have to be equal, don't they?
Yeah, sure.
And this black dot and this black dot have to be equal. And all those black dot triangles all have to be congruent to each other, don't they?
Of course. But
So
that doesn't say but what's mysterious is the blue dot.
Yeah, but looking at then, doesn't that make the star triangles? The star triangles are isn't it like the two circles equals two stars, doesn't it?
Yeah.
Doesn't it?
Yeah.
Doesn't it?
Let me do it myself.
Those are 45-degree angles. I think so.
Yeah.
Two
it's not 45. None of the angles are 45 degrees.
Oh, yeah, you're right.
I'm right. It's a general rectangle. It's not a square.
Yeah, you're right.
Yeah. But
is
I think
true?
my conjecture,
is this true?
My guess, I'm not sure of it. I haven't proved it. My guess is that actually area A equals area B.
Right. Okay.
And let's see if I could prove it. What I'm going to do, I'll use another color.
This test. I may not have the answers to this test.
Hold on.
Let's see. Do I?
I'm busy proving something, so
Let me see.
let's not give me interference. So I'm going to construct two more lines.
I do have the answers to this test. So
shut up.
But I'm not going to say it.
Shut up.
I'm just telling you we have the answer.
Shut up. I am going to prove it.
Okay.
1 is equal the area of the triangles marked 1 are equal. Okay? Right?
Right.
And indeed now so I want to see if the area of I'm interested in whether area B is equal to area A. Now, I certainly this major diagonal bisects the rectangle. Who that with the two red sides? You'll agree to that?
Yeah, of course. Yeah.
Now, second thing is, I think, right. And so what happens? Well, this equals this. Yes. Okay. Here we go. This equals this. So, area of B equals 2 times area 1. Right?
Okay.
And because compare this one, these two triangles are congruent. And B is composed of two congruent triangles next to each other. Yeah. Also, same idea applied to area A. Area A is also equal to 2 times area 1.
Okay.
And therefore, these two are equal. Therefore, area A equals area B. And our intuition, is proven. Okay? And
Yeah.
so as Joel pointed out, the two opposite unshaded triangles together comprise half the area of the whole thing. Therefore, the other half of the area is the rest. So it's half of half. So the fraction is a half of the rest times a half of that is a quarter. And we agree that the answer is a quarter.
Now, of course, someone taking this test, we spent, 20 minutes on this thing. Obviously, you're not going to be sitting there proving congruent triangles. You're never going to get through the test. And these.
Well, it's a guess. Yeah.
You just have to then just trust your intuition. I mean, I don't know whether you're going to sit there, you're going to start doing geometric proofs. You just really, I think symmetry is the key here. You have to observe symmetries. In these problems, axis symmetry and symmetries. You just have to. Yeah. Wow. Tough problem, right?
Yeah.
Tough problem. Let's see if it's right. So what is this?
Well, another way, quick way of seeing it. Another quick way of seeing it I see is I'm going to use a green. I'll use green here. This is cool. This, Control Z. Okay, there we go. This triangle, right? Again, we did this. We went this path already. Yeah, this triangle is equal to the bottom triangle. Yeah. Yes, I'm just repeating the same thing we said before.
Okay, so don't do that. Try to avoid that.
No, again, so this is, a combination. It's a combination of testing one's geometric intuition,
right?
Which for some people might also test their ability to see the mathematical relationships and make deductions more quickly.
But it was
it's a hard problem. Yeah, it's a tricky problem. But I think my guess, again, the uninformed guess, is that people like Joel who took that guess, who made that guess, would get the question right because they made a lucky guess.
Right, but don't forget, I can't honestly say that what I would have done in this problem, because I was listening to Seth carefully, because I know he's a smart guy, and he noted this whole thing that there's a half thing going on here, right? He was the one who noticed that, like it's hard for me to draw these. That basically this stuff that's going on here, right, is half, right? Because there's this, and this make up half of the green.
Yeah.
Right? It's hard for me to change color with this thing, right? This is half of these triangles. So therefore, you just have to figure out what these guys are, take it out of one, and then take a half of the remainder of the big triangle minus the A sides. And I
Yeah.
took a guess.
Well,
That
I
you saw
think
it
I
for
have
him.
another proof idea. Another proof idea. Again,
You like this
take
problem,
our
right? You don't want to let it go.
yeah. No, I don't want to let go.
You don't
Take
want to let it
this.
go. Wait, we have to move
I'm going to
things
use
around a little bit.
arrows.
Hold on. We have to move things. We have to give you more space. I'm sorry, but we have to get used to this new way of doing things. Okay. Okay, go ahead. Now you
Okay.
have some space. Let
So
people see.
I draw the. Sorry. I draw these diagonals. Okay, here we go. So we're wondering about. A versus B. So what is it? The area of A is. Let's use X, Y, Z, and W for variables. The
By the way,
area
if
of
anyone
A.
wants to leave, this
Yeah,
is like
if you want to leave, leave. We
goodbye,
won't be.
goodbye, goodbye. Yeah, you know
Goodbye.
what? You may not want to hear this,
You
and
may not.
but
I
like
don't
us,
think you want to
dislike
hear
us. Yeah, I know. I don't think you want to hear
that.
this. So then just
Yeah.
stay on if you like crazy, okay?
Yeah.
and
Here's
then
X.
we'll see you later. Like us, dislike us, and give us comments at satmathquestion@gmail.com. And we hope to see you again soon. Like hopefully tomorrow.
Yeah. Yeah. X is the distance, is the length of the is the height of the rectangle. Y is half the width.
Right.
And the area of A is 1/2 X times Y.
Well, that's a cute way of doing it.
All right, now.
Wait, but I gotta show this because people don't see it. Okay, there you go.
Now, I have more variables. X and Y, Z is the width of the whole triangle, and W is half the height.
Right.
So area B is a half of W times Z.
Okay.
Okay. Now, however, X equals 2Y, right?
Why does
X equals 2.
Why does X equal 2Y?
No, sorry, I made wrong. Y. Yeah. No, I'm sorry.
No, Y
I'm
is
sorry.
half
I'm
Z.
sorry. Yeah. I made a mistake. Z, right?
Z
is the width of the triangle, and Y is the height of the triangle A.
Yeah, so Z is 2Y.
And so Z is equal to 2Y.
That's right.
And similarly,
X is equal to 2W.
Is equal to 2W.
Right.
Okay? And so let's see. So let's eliminate something. Eliminate Z. We get B is a half of W times 2Y. And eliminate X. For A is a half of 2W times Y.
Yay, Seth.
And we have the same thing.
All right, Seth.
Yeah.
Way to go. Oh, that's nice. That's so much nicer.
And that is something, this is the algebra that expresses the idea, but you could more quickly understand it graphically or geometrically or visually.
Yeah.
Because you see Y and Z. So we have a height. So one triangle is a height times half of a width. That's triangle A. And the other triangle is a width times half of the height.
Yeah.
Both of them times a half.
Right. For
the whole area. And so I think one could see that. But, I didn't see that until messing around with the less efficient ways before.
Right.
So indeed, these certainly, I think it's recognized that and by design, these old SAT tests were had more emphasis on, on the imagination, insight.
Oh, of course, of
Yeah,
course, of course, of course they did. Of course
imagination,
they did.
insight, rather than skill in doing what they taught you in the class.
Absolutely, that was the whole point. Exactly. You
That's
said it. You said it. You said
yeah,
exactly the idea. Okay, everyone. Wow. I don't know. I can't believe anyone has gotten this far in the video. If you had, wow. Okay. I hope you can. I'm sorry. Okay, everyone. So have a great
yeah.
day.
These are tricky.
Yeah, yeah, yeah. This is why we do Throwback Thursday, to get a sense as to what the tests were, so that you can sort of appreciate what the tests are now and understand the difference. Okay, everyone.
Yeah.
So have a great day, and we hope to see you next time we meet, which hopefully be tomorrow. Okay, take care, everyone. Bye.